Hello everyone. Today's topic is moment to force ratio in second order. In this presentation, I will also explain the confusion between moment of couple to moment of force ratio and moment of couple to force ratio, which is also called moment to force ratio. Canine retraction is the best suited example for description of moment to force ratio in the mesodistal plane. So we will discuss how all types of tooth movements are possible with combination of different moment to force ratios for canine retraction. In all examples which are included in this presentation, the distance from the point of force application to center of resistance would be taken as 10 mm and a force of 100 gram is applied for canine retraction, while we have considered mesodistal width of the bracket as 4 mm just for the sake of this presentation. The first example is uncontrolled tipping, where moment of couple to moment of force is equal to 0, while moment of couple to force is less than 1. This happens when we used our removable appliance for canine retraction, or we are retracting the canine without any wire, or we are using a very lighter wire. In uncontrolled tipping, the center of rotation is usually at the center of resistance. If we calculate the moment of force in this case, it would be 100 gram of force multiplied by 10 millimeter of distance. So it would be 1000 gram millimeter. While we are applying no moment of couple, so that would be 0 in this case. So the overall results would be 0 for moment of couple to moment of force. For moment of couple to force ratio, as there is no moment of couple, so similarly the outcome here would also be 0, or that would be less than 1. In second example, that is controlled tipping, the center of rotation is apical to the center of resistance. So the moment of couple to moment of force is greater than 0, but is less than 1, while moment of couple to force ratio is in the range of 1 to 9, because we are taking 10 millimeter as the distance between point of force application to center of resistance. If we had taken this distance like 8 millimeter, then this value would be 1 to 7. So to calculate the moment of couple to moment of force, the moment of force would remain the same as previous example, that would be 1000 gram millimeter. While moment of couple, in this example, we are considering that we have applied 150 gram of force, that is by the insertion of some lighter wires in the canines during its retraction. So the moment of couple in this example is 600 gram millimeter, which is less than moment of force, and the overall results for moment of couple to moment of force are 0.6. So controlled tipping would occur in this case. For moment of couple to force ratio, the moment of couple is same, that is 600 gram millimeter, and as the force is 100 gram, so moment of couple to force will become 6 or 6 millimeter. The third example is translation or bodily retraction of the canine, where moment of couple to moment of force is equal to 1, or moment of couple to force is equal to 10. Here, when the canine is retracted bodily, the center of rotation is at infinity. As we have calculated before, the moment of force will remain 1000 gram millimeter. For bodily retraction, as we have decided a fixed mesodistal width of the bracket, that is 4 millimeter, we need 250 gram of force for the counter movement, that is the moment of couple. So as the moment of couple and moment of force is the same, So the outcome is equal to 1 and canine would be retracted bodily. Similarly, for moment of couple to force ratio, we need to generate 250 gram of force by traction of the wire and brackets to produce a moment of couple of 1000 gram millimeter. So when we have a moment of couple of 1000 gram millimeter, the moment of couple to force ratio would become 10. The last example is torque, where the center of rotation is at the incisor H and only root movement occurs. Here, the moment of couple to moment of force ratio is greater than 1 or moment of couple to force ratio is greater than 10. In this example 2, the moment of force would remain 1000 gram millimeter. But if we apply a greater force of 400 gram, we would generate a moment of couple of 1600 gram millimeter. This greater force is usually produced when we give some gable bands in the wire, or when we insert the bracket at an extra angle, or when we used extra tip in the brackets. So here moment of couple to force ratio is greater than 1, that is 1.6. For moment of couple to force ratio greater than 10 to be produced, we need the same moment of couple of 1600 gram millimeter. So that divided by force will become 16 millimeter or 16. The difference between moment of couple to moment of force and moment of couple to force here is that in moment of couple to force there is no distance, and that's why it is giving a different value. I hope this presentation would be helpful for you. I am thankful to Dr. Hassan Saeed for helping me to make this presentation. Thanks.